Hi gang, we're going to finish up here the last video for assignment number 5, and we're going to go through the required SQL statements here and the exercises. So number 1, let's begin. Create a store procedure called product underscore days of week, listing the product names, descriptions, and the day of the week in which they were sold in ascending order of the day of week. This one's a bit tricky because we changed let me show you our ERD again. Gang, again, if you ever have the luxury, as I mentioned to you more than a few times, if you ever have the luxury of seeing the ERD, always use that because it's a roadmap to how you can do your SQL statements. I'm going to make this a little bit larger so you can see the attributes in our time table. And notice we have time, year, quarter, month, week, date, and time, as well as notes. Notice the data types. They're all some type of int, of course, except for notes, which is a varchar. Other than time, year is actually a year data type. However, there is no year data type in SQL Server. So we're making the year data type in SQL Server as before in a prior video. We're making that a small int so that we can put in years like 2014, 2020. We're making it a small int, whereas a tiny int could not handle those values. So while MySQL can handle a year, SQL Server cannot. The rest of these are tiny ints, which SQL Server also acknowledges, and SQL Server also acknowledges the time data type, but not year. So MySQL, we can have a year. SQL Server, we must make it a small int. Look at our time day. Our time day is a tiny int, and that's important when we do our first exercise. Okay, and so here it is again. Create a store procedure, product days of week, listing the product names, descriptions, and the day of the week in which they were sold in ascending order of the day of the week. Here is our solution. Again, gang, please make sure that you always do the SQL statement first before you do the store procedure. And there's a couple things I want to talk about. First of all, I'm going to make this, everyone's going to get this exercise as a freebie. There's going to be no points associated with this. Number one, because if you look up the requirements of the date name function in SQL Server, it requires 2 arguments. One, the date part, and the date part refers to what do we want? Do we want out of the date part, do we want the week? Do we want the year? Do we want the day? Do we want the day of the week as of Monday, Tuesday, Wednesday, Thursday? Do we want the day, DD? DD would refer to the numeric value of that week. So which part do we want? Well, here we want the alpha value of the day of the week. So in other words, Monday, Tuesday, Wednesday, whatever. We want that alpha value. However, the legitimate, if you will, the legitimate second argument is really a date argument. Well, if you remember, our time day is a tiny int. So we have to do a little jumping through the hoops here to make this work. So I'm not going to count this as part of your the grade because I'm showing you a workaround here. If we actually made this a regular date, this would work. This code would work. We'd need another part of it. We'd have to set the date first property, set date first to 1 because we want 1, meaning Monday, to be the first day of the week in our design. By default, Sunday is the first day of the week, according to SQL Server, so we could change that. But more importantly, we actually made it an integer. So we have to do a little jumping through the hoops here. I just want to show you how this will in fact work, the way we have it set up. What I included, because it was a tiny int, all I did was do an offset. Again, because Sunday is a default start of the week, I just did a 1-day offset, and you could see if we sort these numerically, of course, rather than using the day of the week, Monday, Tuesday, Wednesday, we don't want it alphabetically sorted, we want it numerically sorted. And so, again, let's take a look at this. Always check your values here. Let me do this like this so you can see it better. Also, I'm going to show you something else as well too with this. Text. Let me run this again. And you could see that, in fact, it is working. If you wanted to double check it, all you'd have to do is do something like this to make sure that we're getting day of the week as Monday is 1. All you have to do is this. Instead of DW, just check out date name and how that works. Research date name function in SQL Server. If I did DD and then did this again, you would see that it is evaluating correctly based upon, I think I'm running low of RAM over here because it's running really slow. It's not actually, it's got 8 gigs of RAM. It's because I'm running out of hard space. You can see that the day of week is correct. So Monday, because we artificially created an offset here, the way I did it by just subtracting 1 from the integer value, that it's correctly displaying the right numeric value, or I should say the correct alpha value based upon the numeric value of 1 through 7. So if I change this to show the alpha value of the day of the week, just change that argument to DW. Again, I highly encourage you to research the date name function in SQL Server. I'll run this again, F5, and you can see that it correctly sorts this as we wanted, as your boss wanted. Create a store procedure, product days of week, listing the product names, descriptions, and the day of the week in which they were sold, ascending order of the day of the week. Let's run this whole thing here. I'm going to drop it. The answer really is with the beginning of the store procedure. That's really the answer right there. Okay, but I'm going to drop it, create it, and execute the store procedure. Let's see what happens, and we should get the same return, except for I forgot to change that back to DW. And let me run this again. I'll just run it in here, just change this like this. Day of the week, I want the alpha value rather than the numeric value. F5, and there we go. Okay? So it is correctly evaluating, the order by is correctly evaluating it because it is sorting it numerically, displaying it alphabetically incorrectly, but displaying it numerically correctly, and that's why we have to do the order by time day and setting the offset as we did here. Okay, again, this is a freebie for you guys. If you have any questions about that, post it to the discussion board or send me an email. Okay, one other thing I want to talk about. Look at this print statement I got here. Some of you, I'm sure some of you developers know exactly what that is. And in Windows, I'm doing a carriage return line break. char 13, carriage return. char 10 is a line break. If you're on a Unix system or a Mac system, on Macs, depending if it's pre operating system 10 or 10 10 and above, the line breaks are different on a Mac as well, because as you know, Mac users, as of operating system 10, they went to a Linux-based operating system. So the underlying kernel is actually a Linux kernel, and so it treats it as it would Unix line break. But prior to 10, it was the line breaks were treated, end of line characters were treated differently. On a Windows DOS system, you must include 2 characters, and that is char 13 for character return and char 10 for a line break. What is that going to do? Well, watch. You should see a break after descriptions here. Now, the only way you'll see this is when I display it in text view. If I display this in grid view, you won't see it. So watch. I'll just only do this. You already saw the answer here. So I'm only going to display this print like this. And notice the line break right after descriptions. Now, because SQL Server is residing on a Windows machine on the CCI server, and we're actually going through remote labs to access the SQL Server, but it's on a Windows machine. This is why we have to use the char 13, char 10, both characters to give us the line break. Notice where it's breaking again after descriptions, and as you see it here in descriptions. If I didn't do that, it would do this. Let me show you that. So I'll take this out and show you what it would return as a string. F5, notice how long that is. And we don't want to have to horizontally scroll, right? So we just put those 2 characters in there. Okay, that's that for that. Let's go to number 2. Okay, number 2, create a store procedure listing the product name, quantity on hand, store name, city name, state name, and region name, where each product was purchased in descending order of quantity on hand. And let's go to the solution. Okay, so don't do this, right? Don't do this or allow your users to do that by accident or on purpose, because if all those tables had, if all 6 tables, remember, sorry about that, I gotta turn off my phone, my apologies, sorry about that, because if you had five records in each table, it would be a Cartesian product, right? It would be 5 to the 6th power, which would return with just 6 tables and only 5 records in each table. If we did this product of all 6 tables with only 5 records, by the way, we would return 15,625 records, or possibly more, depending upon how many other records we had in there. So, again, what's the beauty about having a view or a store procedure? Not allowing users to do this by accident or on purpose. Can you imagine if we had millions of records and we did many joins on millions of records in each table? That would surely bring down any server. Okay, so I'm showing you that trick again here with the Windows, by the way, Windows or DOS line break, not Mac and not Unix, but Windows. Here it is. Now, again, the beauty is to be able to have your ERD at your disposal, so you could take a look at it, see what tables. Remember, gang, this is 3784 stuff. You want to find out listing the product name, quantity on hand, store name, city name, state name, region name, where each product was purchased. Find out where all that data resides. And you can see now that with our data store here, that we have many more tables, and many more tables require many more joins. So that can be problematic when we're trying to return this information as we are here. So remember, find out where the attributes are, find out in which tables they reside, do your joins. Here we see we have 1, 2, 3, 4, 5, 6 tables, 5 joins, and that's still a decent number, not a lot, but a decent number of joins here. 1, 2, 3, 4, 5, and 6 tables. So here is the actual answer for this. This will be counted, by the way. Also, we want to format our price and cost. Okay, we want to format our price and cost. So we'll do this. Going to run this, execute it in a drill down method. Copy and paste this. F5. And here, now see, it's not showing everything. Okay, it's easier to see. I could hold the control key down, make it larger, make it easy to read. But the problem is, not all the data is there. I'd have to scroll to the right. So I'm going to put this back in grid view, run this again, and you can see all the data. Okay, there it is right there. Now, unfortunately, I can't make this larger. That's the problem with that. Yeah, so I cannot make this larger. Okay, but it does show everything. Product name, product quantity on hand, cost, price. Notice the cost and price are formatted. Store name, city name, state name, and region name. The 5 we have are North, East, Southwest, and Central. Okay, that is the answer here. Basically, you want to do you want to do the select statement as before. Notice that we don't, again, because we're doing T-SQL, we don't have to change the delimiter, right? Like MySQL, we have to change the delimiter. We don't have to do that in SQL Server. Again, here's your answer. Okay? One more thing. Notice this print statement will not work. The print statement will not work in grid view. It will only work in text view. So let me just show you that. Control A, Control V, F5. Sorry about that. I went back to text view quickly. I didn't want to do that, but if you try this you'll see that if you try this in grid view, that you will not be able to see this print statement. It has to be in text view. Okay? All right, moving on. What's the third one here? Third one is create a store procedure, add payment that adds a payment record, use variables, and pass suitable arguments. Okay, let's do that one. So number 3. Here's how we create our variables in SQL Server. So number 1, what we're doing is if we're creating variables to pass, okay, so again, here's our requirement. Create a store procedure, add payment that adds a payment record. Well, let's look at our payment record. What do we need for a payment record? Always go to the base table to find out. What do we need? Well, we need an ID. We need an invoice ID. We need a pay date. We need a pay amount. And we need pay notes. So 1, 2, 3, 4, 5. The ID should be auto-increment. Really? So only 1, 2, 3, 4. Right? And again, the pay ID should be auto-increment. So what do we have here? Well, in this particular situation, what we're doing is we're actually including create a store procedure, add a payment that adds a payment record, use variables to pass suitable arguments. Now here we're including that invoice ID, right? So invoice ID, pay date, pay amount, pay notes, but we don't need the pay ID because that's auto increment. So here's our store procedure. And by the way, those are the parameters. We don't have to, like we would in MySQL, we would put these in parentheses. We don't do that in SQL Server. These are our parameters in the procedure add payment. So there's a procedure. It accepts 4 parameters. Now what we're going to do is insert into payment. No, again, payment ID is auto increment, so we don't need to use that. Well, I should say more suitably in SQL Server, pay ID is an identity column, right? And so only our primary keys have identity columns because we want them to auto increment. In MySQL it would be auto increment, but in a SQL Server it's an identity column. We're going to insert into payment, and we're going to insert the values that we pass to the store procedure. Now look at that insert statement. We're passing the variables based upon the parameters. So notice invoice ID, I give a suffix to parameters and of underscore P as in Paul, and I give a suffix to variables as underscore V as in Victor. So there's our parameters, and we're going to then insert whatever we pass to the store procedure. We're going to put those values into each one of these attributes. So here's our local variables, which are the parameters of this store procedure. And now they're local variables because parameters are local variables in store procedures, functions, and methods. And now what we're going to do a select before the call. We're going to create our local variables. Why? Because when we execute it, we want to pass those variables locally. And here what we're doing is this. We're creating local variables and we're giving them values. Notice the suffix underscore V for Victor. These are the local variables. We're just giving these literal values. For the invoice ID is 6, date time is there, the amount is there, and the notes is there. Then what we're doing is remember, gang, as I told you a number of times in 3784 and as well as 3781 and other courses as well too, that the calling environment must agree with the method header or the function header or the store procedure header, user-defined function, user-defined method in ton, type, order, and number. So when I say that my store procedure, the first argument must be an int, the second argument must be a date time, the third argument, my apologies, the first parameter, second parameter, third parameter, and fourth parameter in the header are these data types. Then in the calling environment, when I call that store procedure, they must agree in ton, type, int, date time, decimal, and varchar. Order, they must agree in order. So if I am in the header, I have the order of invoice ID, int, date, amount, and notes, and that they must agree in order when I'm calling it. And they must agree in number. So if I have here 4 parameters, I must then first create 4 variables and then pass those arguments. All right, let's see how this works. So here is the answer, and we're creating this store procedure called add payment, and then what we're going to do is declare these local variables right here. Okay, so here it is right here. We create the store procedure, and then I'm going to do the select all payment before the call. I'm going to create local variables, execute the store procedure, passing those arguments, and then notice you can't use parentheses like you would in a normal programming language, and I just put that there as notes. You wouldn't use, just like you wouldn't use, by the way, in the header, you don't use parentheses either, other than for the data types, but you don't use parentheses in the surrounding the parameters. Okay, here's the local variables, here's the execution. I'm going to display the data before the call. I'm going to then, I could also do this, list all the procedures, and then, I'm sorry, my bad, this is it right here before the call. So I'm going to list the table data before the call. I'm then going to declare my local variables, execute the store procedure, and then print the table data after the call. So you could see everything right here. And here it's going to go up to here. This, by the way, will list all the procedures. This will display the definition of a trigger, store procedure, or a view. And then if I want to drop the procedure, I just drop it like this. Okay, so here we go. I'm going to copy this, go into SQL Server, Control A, Control V, run it, and there you can see that I have here 13 records, okay, before the call, right? And now I have here 14 records, including the notes that I put in there, right? Including the notes after the call. Okay, right there. All right, and again, all of it was based upon a store procedure that had 4 parameters. Inside of the body of the store procedure, we inserted, made an insert statement. Again, you don't need the primary key because it's auto increment. Actually, an identity column. And then we created 4 local variables and passed those variables when we executed the store procedure. Okay, let's go to number 4. So number 4, create a store procedure, customer underscore balance, listing the customer's ID, name, invoice ID, total paid on invoice, balance, derived attribute from the difference of a customer's invoice total and the respective payments, and then pass the customer's last name as argument, which may return more than one value. Now, truthfully, if we're going to do this, we wouldn't pass the customer's last name. What we would do is pass their ID, but I use the last name just to show you that you could receive more than one return in the query result set. Let's go to the answer. Okay, so here's our what the exercise is. Here's the actual answer here. It's a store procedure that actually accepts one argument, and therefore it must include one parameter in the store procedure header. What I like to, you could put it all in one line, gang, but what I like to do if there's more than one parameter is put those underneath the create statement, or I should say under the create keyword. So I have here the create for the name of the procedure, create proc, DBO the customer underscore balance, then list all the parameters underneath. Here's the answer right here. Notice what we're doing. I may have forgot to tell you this before, but here we're formatting the dollar amounts using the C currency and what is the localization? The localization is English US. You could do it to whatever environment that you're in. For a global environment, you could say it's France, it's a euro rather than C for currency. There's a lot of different, you could say, and in fact that it's any other type of currency as well too. in Japan, you could say that it's a different type of currency as well in using this particular format. So this is an easy way to format our dollar amounts. Now, because we're using aggregate functions with non-aggregate attributes, per ID, per F name, per L name, and invoice ID, we're using the aggregate function sum, we must include in our group by all of the non-aggregate attributes. For instance, per ID, invoice ID, per last name, per F name, and including the invoice total. Because if you look at over here, we're formatting the invoice total, but it's not used in an aggregate function. Payment amount is used with an aggregate function, but not invoice total. So we have to include that in the group by. Whatever attribute is not used within that aggregate function needs to be placed in a group by. Answer is right here. Okay? And again, because we're going to execute the procedure, store procedure must agree in ton, type, order, and number with the header. We must make sure that when we pass, we make a call to that procedure because it accepts, or I should say in the header has one parameter. We must pass one argument. It must agree in type, order, and number. We only have one, so the number is 1. Must agree in type is a varchar 30. It was declared with a varchar 30, so we must pass an argument with a varchar 30. And then what we're going to do is just run it. So here's our create statement. Then we're going to declare a local variable here and initialize that variable. You could initialize it to an empty string, and if you would just use single quotation marks. Also, it is case sensitive, so here we're just going to pass Smith, execute it. Actually, let me drop that just in case it's already created. I'm going to drop it, create it, declare my local variable, and pass that local variable in the calling environment. And then I'm going to do here is do Control A, Control V to paste it, run it, F5, and there's our return. We could also do this in text, run it again, F5, and you see the text version. I could also do this if I wanted to. I could show the print statement with that. In this particular situation, depending upon how long that print statement is, you want to include your line breaks. As you can see, I included line breaks right here. So I could do something like this. If I am viewing it in text, I'll execute this again. Control A, Control V, F5. And notice we have these suitable line breaks. However, notice though, those line breaks don't take in consideration when we do that. It's still thinking the line's very long, so I have to scroll to the right to see the rest of the data. All that the line breaks do for us is shows the print statement. But if I want to see that without the problem of the print statement, then what I would do is I could eliminate that print statement and just show the return without that print statement, and then it would include all of the data. Okay, and I see, well, not really, because I still have to make the data a little bit smaller so you could see it all. See how it's to the right? So the best way to see this, if you want to see all the data, is just by using the grid view here. Right click on there, right click, results to grid. The problem with grid though, you can't make it larger, right? So see how it shows all the data, but you can't make it larger. At least not in this particular format the way I have it running. Okay, next. Number 5. Create and display the results of a store procedure, store sales between dates that list each store's ID, sum of total sales format, and years for a given time period by passing the start end dates, group by years, sort by total sales, then years, both in descending order. Okay, here's number 5. I'm not going to show you this. You already know about that, the print statement. Let me just show you the answer here. I have a store procedure. You could probably guess right now pretty quickly that it takes 2 parameters. The name is store sales between dates. It takes 2 parameters. They're both small int. Why? Because we made the date here in SQL Server. We made the date for our sale table to be a, what is that? Yeah, we're passing a small int because our date year, my apologies, our date year in the timetable, the date year in MySQL is a year data type, but we don't have a year data type in MySQL. So we had to make it a small int, as you may or may not recall in the previous videos. When we did our create statements, if you did the create statements as per the videos, when you go to the time data type, the time table, you'll see that the time year data type is in fact a small int. Again, because SQL Server does not acknowledge the year data type. All right, here is the answer. Notice how we're displaying it. We're formatting it using the C for currency, English, US. We want to format it like that. Because we're using a aggregate function, sum, with a non-aggregate attribute, we have to include the non-aggregate attributes in the group by statement. So not only are we using store ID, but we're also including time year right here as part of our select statement. So because we're doing that in our group by, we must include time year and store ID in the group by, because those are the non-aggregate attributes. Let's run this. Because we have a store procedure that has 2 parameters, we're going to create our local variables. And we're just using generic ones. You may want to look at what dates you have or what years you have in your timetable. If you followed the videos before, you'll have the same data that I do. And so I took these 2 years, 2010, 2013. I'm going to execute this and see what we return. So Control A, Control V, F5, and we see here is our data. Let me do this one so you may be able to see a little bit better here. Let me do right click on here and show that in grid view. I'm going to run this again. F5. Oops, I don't think I did. Not grid view, I'm sorry. Results to text. Run it again, F5, and there you could see the results a little bit larger when I do this. Okay, there it is right there. Okay, and what we're showing is the store ID, the total sales, and time as year. Again, because I'm showing it in results by text, I gotta scroll to the right to actually see the year. Okay, it's one of the downsides of results to text. Okay, but that is the return. And one more time here in grid view. So it's concise, but again small. There it is. Okay. Number 6. This is a very cool one. As a matter of fact, I made an image for you so you could see how this works. Now, this really is used for data validation. Okay, create a trigger that updates an invoice record after a payment has been made, indicating whether or not the invoice has been paid. Create a trigger that updates an invoice record after payment has been made, indicating whether or not the invoice has been paid. Let's go back to our ERD. The two tables we're looking at right here are invoice and payment. Now, how does that work? Well, we have an invoice total and we have an invoice paid attribute in the invoice table. It's a bit value, very small data type, and we're saying that 1 is paid, true, 0 is off or unpaid. And now what we're doing is trying to get the sums of all the payments made to this invoice ID and finding out if the sums of these payments are equal to or greater than the invoice total. If it is so, then what we're going to do is set that invoice paid bit value to a 1. If not, we're going to keep it as 0. All right, now, what are we doing here? Let's take a look at the trigger. Here's solution number 6. Here's a couple things going on. The actual answer is right here. Okay? Look what's happening here. A lot of stuff is going on. Number 1, what we do for, I'll change this, for testing, and really it is testing data validation. Okay? We're setting all the invoice paid attribute values in the invoice table. Now, you would never do this in a production database, right? We're setting this value for invoice paid, the bit value, regardless of what it is currently. They could all be 1s for that matter. In other words, they're all paid up. But to test this, we're setting the invoice paid bit value to 0. That means unpaid. And then what we're doing is we're checking here. By the way, this is a slick little join here. We're updating the invoice table. We're setting invoice paid equals 1, in other words, true, from invoice as I. And what we're doing is joining the invoice table with the payment table. We're saying select invoice ID, the sum of all the payments as total paid. From the payment table, we're going to group by invoice ID as V. So this is going to be, this select is going to be as V, and then we're going to join that, the invoice I, this table as I, the alias, and this table, this select statement as V, and we're going to join it on the invoice ID. In other words, what we're doing is we're joining, making sure that we have the correct invoice ID from the invoice table to the payment table. We want to make sure that is the exact same invoice ID. We're joining that. We're summing all the payments, making sure that we've got the same correct invoice ID. And then what we're doing is saying where total paid is greater than or equal to the invoice total. So the total paid, in other words, this alias, the sum of all the payments as total paid is greater than or equal to the actual invoice total. And if it is, what we're going to do is we're going to update that invoice paid attribute to 1. Let's see how this works. Okay, so I'm going to drop the trigger, create the trigger, set all of the invoice paid values to 0 to test it, and then what I'm going to do is update the invoice, set the invoice paid ID, invoice paid value to 1, but only if the sum of all the payments is greater than or equal to the invoice total. I'm going to select all from invoice. I'm going to, the trigger that fires it is an insert. So I'm going to insert into payment. Here's my values. And then I'm going to print all of the values after the trigger fires. So I'm going to print the values of the invoice. I'm going to fire the trigger based upon an insert into payment. Then I'm going to select everything from invoice, everything from payment, Then I'm also going to do this. I'm going to display the sum of the payments for each invoice. And I actually created an image for you too to show you how this works. I'm going to copy this, select all, paste, and then run this. Okay, now gang, you probably can't see this, but I created an image here for you so you could see the actual return. Here's the return right here. By the way, this will help simplify it too. This is the exact return that you're seeing here, simplified in this image. And what I did was I took this return, this query result set, or I should say these query result sets, 1, 2, 3, and 4, and I made it an image. So here is let me do this. Here is the first select all from invoice. Okay? Right here. This top one. And notice that because I tripped the invoice paid and I said, let's set all these to 0. Okay? So here's before the trigger. I'm setting the invoice paid, or I should say, it's inside the trigger, but before the values, it's inside the trigger, which is making this update here, set it to 0. Before the trigger actually updates the invoice paid, the first thing it's doing, it's setting them all to 0. Now next, what I'm doing is this. So I do a select before the trigger's fired. I then fire the trigger, and then I list the tables after. So here's the invoice before, right here at the top, all selected to 0. I fire the trigger, and what I'm doing here then is making that same comparison. So you can see here in the first one, invoice ID 1 through 10. Here's 1 through 10. Notice that when the trigger's fired and the payments are made, and this update statement is working, okay, when this update statement works, then it's comparing the values. Okay, we're saying invoice paid is 1, invoice paid is 1, invoice paid is 1, and 1. In other words, these are all paid. Now look at the invoice ID. So 3 is paid, 4 is paid, 6 is paid, and 9 is paid. Well, notice what I did to make this simple to see. The invoice total for all of these are 100. I just set them as 100 arbitrarily to show you the payments made in the payment table. Look at the third result set here. Here are the payments made in the payment table. Now, notice that more than one payment is assigned to invoice ID. So say here, invoice ID number 3 has a payment of 50, and then again, invoice ID 3 has a payment of 75. Invoice ID 4 has a payment of 50, and invoice ID 4 has another payment of 60. So those are all the individual payments. Now I did a sum of all these payments right here. So I did another select statement right here to show you the sum of all the payments based upon the ID, and because I did a aggregate function with a non-aggregate attribute, invoice ID, I had a group by invoice ID. Now when I did that, look at this comparison. Invoice ID, payment sum is 50. Well, it has a total of 100, so you can see it's not paid. Look at the sum for invoice ID 2. It too is 50, and you can see that up here in the second result set, it's unpaid. But look at invoice ID 3. Remember, I set all the invoice totals to 100 to make it easy to see. Look at invoice ID 3, 125. That should be paid. And in fact, if you look over here, the bit value has been flipped to 1. Same with invoice ID 4, same with invoice ID 6 and 9. Take a look at this result set from here, showing you the sum of all the payments. And you could see where it's more or equal to 100, invoice ID 3, 4, 6, and 9, in fact, is 100, which is still greater than or equal to 100, meaning that it's paid, those bit values have been flipped to 1. Again, gang, this is just showing you a trigger that will automatically do data validation, even though we automatically set the invoice paid attribute to 0, so we could made all of the invoice paid to 0, and then included this update statement, and it did data validation on all of our invoice records. So again, it's just showing you how to do a trigger to do data validation. And again, your answer is here. Okay? Last but not least, extra credit. Create and display the results of a store procedure order line total that calculates the total price for each order line based upon the product priced times the product. Talking too fast. I got to slow down. Create and display the results of a store procedure called order line total. That calculates the total price for each order line based upon the product priced times the quantity, which yields a subtotal called order line underscore price. The total column includes a 6% sales tax. Query result set should display the order line ID, product ID, name, description, price, order line quantity, subtotal, and the total with the 6% total 6% sales tax. As you can see, I specifically broke these out into order line ID, product ID, name, description, price, the order line quantity, the order line price, and the total with this 6% sales tax. Notice the 6% sales tax is different than the order line price. Okay, let's look at the answer. And here it is right here. Okay, this is the extra credit. Notice the formatting that we're doing, SQL Server formatting, using the C for currency, English US format. You can change that whatever localization you want to. Here is, again, the answer. Here you could pause that. Here is the full drop procedure, create procedure. And because we're not using any parameters, we're just going to execute the store procedure called order line, order underscore line underscore total. Copy that, paste that in SQL Server, and run it. And I'm going to show this in a text view as well. Okay, again, I either make this smaller or scroll. I'm going to make this smaller, but notice I still have to scroll here. Okay, but here is the data. I showed it to you in the assignment in a more readable format. So that's what you should return. These values should be the same if you use the data that I used in the videos. All right, gang, if you have any questions, please post them to the discussion board or email me. See you in class.